Hello and welcome. Today we're going to be talking about and giving you a introduction to FieldView version 2023, which was released last month and is now available at the portal, mytecplot.com. My name is Shane Wagner. I'm an account manager here at Tecplot. That's me on the far left of this picture. And on the far right is Yves-Marie Lefebvre, CTO of Tecplot Inc. And we are bookends there with some of our other colleagues at Tecplot, which is a reminder that FieldView is now part of the Tecplot family, along with Tecplot 360 and Tecplot RS. So today, as I mentioned, we're going to be talking about FieldView version 2023, which was released on November 10th. First off, we'll be looking at the new client server Autostart. That's a way to make things easier for doing client server in parallel for high performance computing systems. We'll show you a new feature that allows you, with a push of a button, to show the min and max on any scalar surface. Review the new Arctan2 scalar. Tell you about the new Polyspheres. We've added key modifiers for mouse buttons for those people using laptops and Macs. If you don't have a 3-button mouse, there's some improvements there. We've improved a number of readers, including the VTK, Tecplot, Ensight, and there's an update to the ANSYS Fluent CFF reader. We've made performance improvements for data sets with many grids on Windows, and the desktop shortcut will automatically be created during installation for Windows. In addition, every time we come out with a new release, we try to fix as many bugs as we can to increase reliability and performance. And we've done that again this time. And as I said, at the end, we'll take your questions in the Q&A. And with that, I'm going to pass things over to Yves-Marie Lefebvre. Yves-Marie, take it away.
Thank you, Shane. Thank you, and hello, welcome everyone to this FieldView 2023 introduction. So let's move on to our first topic. And before I go over the improvements we've made to the client-server mode in FieldView, I want to take a step back and remind our users of the different options we have in FieldView when working with remote data, right? If you're running your CFD simulation on a cluster, maybe a shared corporate resource, maybe it's a department resource, maybe you're running in the cloud. Once you have the data, you have the simulation results over there. Most of the time, you're trying to avoid having to bring it back to your local workstation. So FieldView has a couple of options for you in that case. The first one is to do remote graphics. If you have a system that is capable, a remote system that is capable of doing graphics, if you have a GPU, maybe on a visualization node on your cluster, then you can use a remote graphic environment such as VNC, DCV. FieldView works great in that mode, and you're going to leverage the hardware resources of the visualization node. The second option, second bullet over here, is to run in batch. Maybe the cluster doesn't have a GPU, or you have to resort to using a compute node that doesn't have a GPU. In that case, you can run FieldView in full on the remote machine, but in batch. I've just reminded you of the command line options over here for running FieldView in batch and submitting a script that is going to contain all the instructions for FieldView to operate, load your data, create the geometries, create the surfaces, and save maybe an image or maybe videos. And the third option that we are going to spend more time talking about today is what we call client server. And to really define the conventions, what we mean by the client is the FieldView GUI, the FieldView graphics engine, everything that is local, that is running on your local machine. You could be working from home, maybe on your laptop, or you're working on a workstation at the office, and you're accessing a remote machine on which we have FieldView server processes running. And it is those processes that are going to do the heavy lifting with your data. It's going to be loading, the case, it's going to be creating the surfaces. So you really have instructions going one way from the client to the server, and you have your surfaces and lines traveling back through the network. And once they're on your local system, they are being rendered locally, and you can work on them locally. So this mode of operation, client-server, has been around for a very long time. It relies on what we call server config files for telling FieldView how you're going to run and where to find the bits on the remote machine. And you can go all the way to package all the necessary information for FieldView to fire up the remote servers and connect to that machine automatically. This is what we call client-server Autostart. So you typically set up these files. We like to work with your IT groups or your methods group to set them up. And once you have them, FieldView feeds the files at startup, and they populate the drop-down list in the server configuration area of the data input panel. You can see over here that I have the defaults plus the server configuration files that I've defined for myself over here. And the content can be very simple if I'm just running in parallel on 9 processors over here. It can be quite concise, or it can be a bit more complex if I have a more complex environment. But again, this is the infrastructure that has been working well for many years for customers working with client server. However, we realize that for more complex environments, again, I'm talking about maybe you have a corporate HPC resource or you're running in the cloud, you end up having an environment that is not necessarily super easy for doing the client server startup. Difficulties like having firewalls between your local machine and the login node of the cluster, only being allowed to connect to a login node and then having to submit your jobs on a job scheduler, like PBS, for instance, is another difficulty. And once you get assigned some nodes, well, you don't know ahead of time which nodes you're going to get. And so you don't know what nodes need to be connected from the local client to the FieldView servers. So a lot of additional difficulties for modern high-performance computing systems nowadays. And honestly, for very advanced users, it was doable to do client-server, but most of the time they had to resort to doing what we call manual mode. So in this screen grab over here, I'm showing you what it's typically like to do the manual mode. Basically, you're telling FieldView, I want to do client server, but I'll do everything myself. And then FieldView stops, and it lets you connect through a terminal and SSH to that remote machine, fire up the servers yourself, and establish a connection back to the client. It's doable, but we recognize that it was difficult to do, and that only the most advanced users will remember how to do that from session to session. So it is this challenge that we wanted to address with this new capability. So on this slide, I'm coming then to the solutions that we've implemented. So basically, the new capability for client server Autostart is going to support port forwarding. So first we go from the local client, which is going to use either SSH or PuTTY, whatever SSH client you have installed on your machine and that you prefer. We do that because we want to use the security that you have. For instance, we've tested extensively FieldView with a Kerberized version of SSH for very high security. So that works, and FieldView can use that SSH for establishing the connection to the remote login node. Once connected to the login node, FieldView will by itself submit a job for getting some compute node resources on which FieldView will then be launched. At this stage, we started by supporting PBS only. That's a limitation for this first version. We started with PBS because it is our experience that this is the most widely used job scheduler among our customer base. But we started the work to have support for other job schedulers. We'll be starting with Slurm first, and then extending to LSF. So no worries if you don't use PBS, but please let us know, because it will also help us to prioritize the work in the follow-up versions after FieldView 2023. And once the resources have been obtained, the FieldView servers have been started, they are going to connect back to the client, and we support double port forwarding from the compute node to the local machine. And again, this is all done automatically by FieldView. So I know it sounds a bit complicated, but we really designed it in a way that we can work with you on setting up the server configuration file. You do it once and for all, and after that you can forget about that and keep using client server, and it makes it a push button operation. I'm going to show you that in a recorded video, in a recorded demo in a second. Before I do that, one additional thing that I want to mention, we took advantage of this work and extensive testing of client server and parallel to also upgrade the version of OpenMPI that is distributed with FieldView. So we went up to OpenMPI 4.1.5, and this is going to ensure much better compatibility with your HPC environment, especially the interconnect that is used for the connection between the compute nodes. And so it ensures better portability for FieldView parallel on modern HPC systems. So we supported these additional capabilities by extending the existing infrastructure we had for the server configuration files. Here I'm showing you an example of some of the additional entries in that file that are now available. So in red, you can see that now you can set up the scheduler. So again, for now, we support PBS, but very quickly we'll support Slurm and LSF as well. You can do things like specifying the queue in which the request will be placed, the maximum job time before the job gets scaled. If you have an allocation, if you have a budget for CPU resources, for CPU time on the cluster, you can put that in. So you have all of these settings. And then you have some additional options for defining the type of node and the number of nodes that you're going to request. And on the other end, from the GUI point of view, we have a new panel telling you what is happening, because obviously if you submit the job request in a queue, you may have to wait for the job to be started. And so we wanted FieldView to give you a clue of what is happening. So it's confirming that it's not dead, it's waiting for the job to start, and it's giving you feedback on when it's been submitted and what is happening with your job. So that will be happening through this new panel. All right, so with that, let's go through a demonstration. So here we're going for a client server configuration file that we've prepared. As you can see, we have the new panel over here, which is attempting the connection. The connection has been established to the remote cluster, and we can see that the job has been submitted. At the bottom, what our demonstrator is doing is opening a terminal to show the status of the job. We are tracking it in the queue, so the job is in queue state, it's been submitted. In the upper right corner, we're just showing you that a log is being written locally. You don't need to worry about that if there's no problem, but this is going to be very convenient for setting up the server configuration file initially. And yeah, on the left is just a normal terminal window for FieldView. Okay, so we got the message that the job has changed status, moved on to running. The FieldView servers have been started, and so yeah, it kind of went a bit quickly, but the user has been able to browse on the remote machine and pick the grid that he wanted to read. So now FieldView is just going to proceed as usual. Here we're going to say that we are taking it very far. We are running on 32 cores using 4 nodes on the cluster, so it's taking a bit more time to fire up all the processes. But once it does so, it's going to read our plot 3D case. Yeah, so now we can see in the bottom left the typical message that you're seeing with the various grids being sent to the parallel processes, and the grid is being read. So if I just jump over on time a tiny bit, after that, yep, so we can see the grid with its outline in the background. So FieldView is done with reading the grid, and the next step is for it to read the results, since we are working with a plot3D file. And after that, you just work with FieldView as you've always done. You don't need to worry about the fact that the data is remote. Over here, we're going to go ahead and create some surfaces. So we start with some boundary surfaces at first. Yeah, so you can see that we are working with a wing profile. Then the user is making cuts. So the only difference really that affects the way you read the data initially, and you may have a bit of wait for the job scheduler to get you your resources. But after that, you work with FieldView as you typically do, and you don't need to worry about the fact that your data is remote. So finishing up with two kind of extreme examples over here. If we look at the typical configuration file for a case where you're running on the node with a lot of memory, what I'm representing in this diagram is the idea of having all of these server processes potentially running on that single node. This is really what is going to give you the best performance in parallel if you have the memory, because then there's no communication between the nodes on the cluster. So you'll get the best speed up. So that will be one way to do it. And here we're using a scheduler option, saying calling the node big mem. So that's a typical option for PBS for such a node, and that will make sure that if you have an heterogeneous HPC cluster, it's making sure that you're taking the node that you want to use. And if we take the extreme opposite example, let's say that you're running on a cluster with only compute nodes, and the compute nodes have very little memory for each node. In that case, you may want to run a single FieldView server process per node to add up the memory from the maximum number of nodes so that you have enough memory for loading the entire case. So here we are matching the number of CPUs and number of nodes to have a single process per node. And just to wrap it up on this topic, just want to remind you that you really have two motivations in FieldView for running in parallel. It could be that, as I was showing in the previous slide, you want to add more memory by using a cluster parallel mode that lets you add the memory from the several nodes that you're running on. But also you're getting some speed ups, obviously, by using our MPI parallelization. The speed ups depends on your operation. So I try to always give you a realistic overall speed up. You typically get some good initial speed up for the read, particularly, until you reach some hardware contingency. But other things like computing an ISO surface, for instance, that spreads through a lot of your data and a lot of the partitions are going to continue to give you additional speed up, higher core counts. So here, for this particular case where we're monitoring the time to load the case, create the wing profile, and create this pretty rich ISO surface, you can see the time that it takes to do the entire operation shown in this histogram, from going serial to parallel 8, which is a standard FieldView license. And then if you want to go for one of our parallel options, which allows you to do up to 64 cores, you can get additional speed up with that. All right, at that stage, I want to stop, Shane, and see whether we have any questions. This is kind of the end of the first section of this presentation on client server and parallel. So that will be a good time for answering questions on this part of the presentation, if you have any.
Yes, sure. Okay, so we do have two questions. One is, Is this presentation valid for FieldView version 2022? The answer to that is no. This is specifically about the new version released November 10th, FieldView version 2023. It is available on mytecplot.com on the portal, so go ahead and upgrade if you want any of these new features.
Yeah, and a reminder
Yep.
for users, Shane, that people don't need a new password. If they have a valid and supported FieldView password, they can just download and run the new version with it. We changed the way in the past couple of years ago, with every new release, you needed to have a new flex key. We don't use the system anymore, and so there's a different encoding of your maintenance in the password. And so you will not need a new password for running this version. You should have everything you need already.
Right. So if you're running version 2022, you won't need a new key when you download 2023.
Yep.
Okay. So the second question is about their hardware. It says, our cluster has visualization nodes. Will I be able to take advantage of that?
Yes, absolutely. So what people typically mean by visualization node is that they have nodes that are more used for pre and post for their CFD, running the measure and running the post-processing. So they typically have a lot of memory. And so they can be convenient for doing exactly what I was showing over here. If they want to run on a single node, that will be perfect if they have enough memory for loading the entire dataset. And sometimes, yeah, the scheduler option will be big memory. If they want to reserve specifically a vs node, and this vs node has a GPU, and this job scheduler knows about that. Another trick could be to use a scheduler option with num GPU equals 1 to force the reservation of that visualization node. So that's one option. But if you have a vs node, it's also a good place for running FieldView in full and maybe sending back the graphics. So you have plenty of options if you have such a vs node, and doing client server is one of them.
Okay, thank you. And as a reminder, we will be answering questions if people wants to use the chat feature anytime. I'll be answering on your behalf. So if you have a question, please write it out in the question box and on the GoToWebinar interface there, and I will read them on your behalf. But that's all we have for now.
All right, thank you, Shane. So let's proceed then, and we'll move on to other new capabilities. We'll spend a shorter amount of time on each one of them because they are smaller things, but I believe there are some really nice new features in that version. The first one is the one we call Scalar Min Max. So the challenge on this one is illustrated in this case. So we have here a headlamp simulation. So we are making a cut through it to look at the temperature field. And typically what you want to do here is look at the hotspots. So if you go to the color map tab for FieldView, you have the option to turn on local, and FieldView will right away give you the right color map range to fit the current surface. So that tells you the min and max values, and you can see kind of whereabouts they are. But it doesn't tell you the exact value and the exact location of that Scalar Min Max. So that's what was missing so far. Address this, we are introducing a new capability, which is again called Scalar Min Max, that you can see over here. And when you turn it on, it's going to give you a dot showing the location of the min and max for your current scalar, as well as the value. It's going to be available for all surface types, so you're going to have the same option. And after you turn it on, you can also look at the options. So I'm showing up the Scalar Min Max options panel over here. And what it lets you do is control totally separately what you do for the minimum and maximum. Maybe you want to just look at the max or just look at the min. And you can also fully customize the label that we are placing there. And I'll show you that in details in a demonstration in the next slide. So here we are going to activate Scalar Min Max. You can see that by default, you get them in a fixed color, you get a dot and a label. The label is, we are using a trick graphically to always put it on top. We are assuming that you want to that text to be readable. That's why it's always on top. So as I mentioned, then you can control separately the min and max. Maybe you want to focus on the max. You have the ability to change the color as well. With by default, we're showing you the 10 colors, but you have access to any colors that you want. And then you can change the font size and the font as well for customization. The label is by default pretty long. We're trying to be exhaustive. You can type in that field, say that you want to add the unit, you can do that. If you want to make it shorter, you can replace one of the escape sequence. The first one is to give you the scalar name. You can replace it with just tmin, if that's more concise. And then we can also use the formatting for having exactly the number of digits that we want. So we use a four-tone style formatting. And if you're not sure about the syntax, you can hover over the label and the field, and it's going to give you the syntax for the formatting. And you can also use an escape sequence for showing the location of the surface. So here you can see that once we have it ready, we can change the location of the plane and everything changes simultaneously, the location, the value of min and max, also the location of that plane that we've added in that field. So quite a powerful capability. We're getting really good feedback about this capability. And I've got to mention as well that it is a user feature request from a very experienced aerospace FieldView customer. So please feel free to send us your feature requests as well. If they line up with what other customers want to see, the chances are high that we're going to implement them. All right, let's move on to the next thing, which is as well a feature request. So the challenge over here was for customers using arctangent to compute the local angle of attack. FieldView was only providing the arctangent function. And so that was causing issues when the horizontal component of velocity was reversing. In areas like this or this, you could see that we had strong discontinuity, and then the value of local angle of attack that was being computed was non-physical. So to fix that, we introduced a second arctangent function, arctangent2. Over here, we had to rearrange a little bit the panel to make room for it. And yeah, let me show you in the demonstration how it works. So here we're using multiple windows. We're doing a copy so that we'll be able to compare the old and the new function. So FieldView is copying the data at the bottom. Okay, and now we're going to create that new variable. So arctangent2, again, we have a tooltip. If you hover over it, we are using the C syntax. So it's arctangent2. So first, we expect the numerator, comma, and the denominator. So in that case, the numerator is going to be the vertical component of velocity. We're using a filter over here with 3 letters. We get only the velocity functions, then comma and the horizontal component of velocity, and we conclude the formula. All right, then we're going to use it at the bottom. You can see that the legend shows us automatically the name of that legend, and I'm just importing a different color map over here because obviously the range is different between arctangent2 and arctangent. So we need to go from we need the color map to go from -pi to pi in this case instead of -pi/2 to pi/2. So that's why we made that change. But after that, you can see that the fields totally match, and especially if we zoom in the parameter areas that we identified earlier, they're gone, and we have physical and continuous values of local angle of attack now with this new function. All right, moving on. The next new feature, we're calling it Polyspheres. So the challenge in this case was for our customers using the particle path format for representing more the location of some data. For instance, this is very useful for cases where you have pressure probe values that you're trying to represent on a CFD solution. The problem with pressure probe is that they're on the surface, and with the spheres that FieldView was using so far, you were getting some weird artifacts on geometries at the intersection. The reason for that is that for being fast, FieldView is using a graphics trick that allows us to be very fast for rendering up to, let's say, dozens of millions of particles. But the trick is that it's not really actual spheres that we are dealing with. So what we did was to add an option to have you render actual spheres. We're calling them polyspheres. And those spheres have a perfect intersection with the surfaces that you place them on. So that gives you this much better, much more accurate view over here. The caveat being that we are rendering actual spheres, so they're going to be more GPU intensive to render. And so we only recommend using that polyspheres mode when you have a smaller number of spheres, up to a few hundreds, maybe a few thousands. But after that, the frame rate is going to go down, and we recommend switching back to spheres if you have more glyphs that you want to show. Then we worked on our key modifiers for the view controls. So our FieldView users in the meeting are probably very familiar with the 3 mouse buttons that we use by default. So left mouse is translation, center mouse is rotation, right mouse button is zoom. That's what you get by default. But then the challenge is for customers who work on a system that doesn't provide 3 buttons on the mouse. Maybe you're using a touchpad or a trackpad on the laptop. Maybe you're using a magic mouse. So we needed a way for you to continue working in such an environment. So we introduced some key modifiers. We have 2 sets, one for the Mac, because they are the typical key modifiers on this environment. So you use Option and Control. And for Windows and Linux, you can use Alt and Alt-Shift. So Alt for getting the center mouse button and Alt-Shift for getting the right mouse button. And with that, with any control device, you'll always be able to adjust the view the way you want in FieldView. Moving on to our typical section on readers, we try to improve and increase the number of readers that we support with every version of FieldView. In this one, we did a lot of work around VTK. There was particularly a sub-format of VTK that we are not supporting yet, called VTI. So VTI is the VTK image data. It is a regular array of points, as we are seeing in the data set on the right, meaning that it is, really regular. You got to think about it like an image in 3D. That's really where that's coming from. And that format is being used by a growing number of Cartesian solvers. In our aerospace field, we especially see results being exported from the Create AV solvers, Julius and Castrel, for the Cartesian off-body mesh being saved to VTI. So that was one of the motivations, but several of the solvers are using this format. So we read it in 2 ways. You may not know it, but FieldView has 2 VTK readers. But under the hood, that's just to match the fact that FieldView can work with structured data or unstructured data. Under the hood, we read many of the VTK formats. So if you read that VTI file with a VTK structured reader, FieldView is going to preserve the Cartesian nature of the information and use all of the internal optimizations in FieldView for being fast and memory efficient at working with this Cartesian data. If you want to couple this VTI data with other VTK formats like VTU, for instance, inside a VTM file, which is kind of a metadata file around it, then you have to read the VTI through the VTK unstructured hybrid reader. And what's going to happen is that the VTI data is going to be converted to unstructured data on the fly to be matching the rest of your VTM file. So you have both options. We also did some work, particularly for the VTK reader, but that also affects other data formats when you have a changing number of grids over time, because FieldView tries to be smart and has some optimizations for going faster from time step to time step. And so when it detects that you may have different number of grids, it's going to ask you whether that's the case and then turn off the optimizations. Be a bit slower, but it's also going to be more reliable going from time step to time step. And finally, with regards to the VTU to the VTK formats in general, we've added support for eye blanking information in VTU datasets. In VTU, eye blanking gets stored under a variable called VTK ghost type. So far, this field was being ignored, so now it's being loaded. The caveat is that FieldView, when dealing with unstructured data, doesn't have real support for eye blanking. It's only supported for structured data. But what we do is that we still load VTK ghost type as a scalar, and then that lets you use that scalar for doing things like thresholding for filtering out portions of your dataset. So it's quite close in terms of behavior. We also brought to the surface two readers that we had for a long time, but users were often asking us about them, not finding them on the interface. They were a bit hidden under something called generic unstructured, but FieldView has readers for both the Tecplot 360 format and the Ensight format, and so you'll find them directly now in the drop-down list. And with that, that wraps up my update. But here is a full list of capabilities. If you want to get access to that list, it is also available on our website if you go to the FieldView page. And again, the new version, FieldView 2023, is available on the portal, mytecplot.com, and you can download and install and run it if you have a supported password. FieldView will run automatically with that password. They will find it from your previous installation as much as possible and use it with a new version. So with that, I'm going back to you, Shane, for wrapping it up and see if we have any additional question.
Well, great. Thank you so much for that presentation. And yes, we do have some questions. As I mentioned, we're going to do a Q&A now, and if you haven't figured it out yet, you can still go to the chat feature in the GoToWebinar interface there and ask us any question. There are a few questions. I'll try to go in an order that kind of makes sense to the presentation. One is about the VTK slide and asking about what type of scan that 3D scan was. I think that was an example file.
Yes, this is actually one of the VTI examples that I downloaded from the internet. So I don't have a lot of information about this data set. It is indeed medical imagery.
Yeah.
It is a scan, but I can't provide any detail on that.
Okay. All right. Thanks. The next question is about speedups using parallel for transient data. Are there significant speedups when reading transient data in parallel?
Okay. So for transient, FieldView does not do parallelization over time. The FieldView parallelization is based on the partitions in your data. So from that point of view, you're not going to get additional speed up from working with transient compared to working with steady state. So if you load your steady state case and you see a speed up reading the case and creating the surfaces and so on, the same speed up is going to apply to when you move to the next time step and the next time step and so on. So the speed ups, the additional performance are going to add up And for instance, it is really interesting to use parallel when you're doing things like creating a pretty long video where you have to go through a lot of time steps and compute complex surfaces for each time step. If you're doing such a process where CPU and file I/O are going to dominate over the rendering and outputting the image, parallel is going to speed up your operation and allow you to do things like, well, yeah, getting the end video sooner, or maybe produce more videos in the same amount of time. But it's just that the speed ups that you get for one time step add up. There's no parallelization over time in FieldView.
Okay, right. So it's the same story whether it's transient or steady state. The types of things that are sped up by parallel are data reading and computing large things, but not everything. Yep. Sorry, you already said that. The next question is a little more complicated, and I think it goes back to the beginning of showing the server config file and how things get going. The question, the person who's asking is saying they're not really clear how the server is set up. Not familiar with the server config.
Mm-hmm.
I've only run FieldView locally in parallel or in batch mode. Could you explain how to set up a configuration file for running on an HPC system?
Yeah, I'm not sure we want to answer that in detail in this meeting, just because this is really something that we like to help our customers with. And funny story, I was visiting a customer a couple of weeks ago, right after the release, and I actually had forgotten that they were using client server. And they said, yeah, we use it all the time. We set up the client server files probably like 10 years ago and never had to touch them again. And so it's not that they really need to understand how to do the client server configuration file. Someone has to work with us at some stage to establish the files. The procedure is fully described in our documentation, of course, so it's also possible for customers to do it by themselves. But I think it's better that we follow up with that person and maybe have a quick follow-up call to explain the basics, provide some configuration file examples, and then we'll iron out any issue. But basically, the file is going to know the name of the remote server that you want to connect to. If not the name, you can provide the IP. It's going to have where are the server executables on that system so that we can launch them. And then I was showing in the examples things like your queuing system, what queue you want to run on. If you have to go through that, there's about 20 entries overall in that file that you may have to fill in. But again, the goal is really to worry about it once and then put it in the right spot and just forget about them and use the files.
Okay, good. And good idea. We'll follow up with that user offline. We have his email. And so on to the next.
Yeah, and if you're not the right person for that, don't hesitate to put us in contact with your IT group or your methods group, or maybe we can arrange an on-site visit. It's just that it may sound complicated, but it's not. It's just things that our support people have been going through a few times in different environments, and so they can easily take care of that. But I think it's better for FieldView users continue to worry about CFD workflows and looking at simulation results and not server configuration files.
Right. Okay. Okay. So the next question is: have there been any updates to the CGNS reader, specifically for region duplication and rotation?
Okay, that's an interesting question. No, there hasn't been any work done in this version on CGNS. This is also a question, well, a contact I'd like to follow up with, because We don't get a lot of requests for work on CGNS on the FieldView end. And so I'd like to better understand the problem and the motivation to correctly prioritize this work.
Okay. And let's see, will we be adding more more features like flow vorticity? Any more features? Yeah.
Okay, I'm not sure I understand this question. Probably, I imagine the user is asking about ways to look at vorticity or look at flow features. I imagine. Yes, we have some ideas in the pipe. I'm not sure yet exactly when they're going to come up, but mostly these ideas are rotating around using newer technology for which there's a prerequisite that our team has started working on. So I don't want to say too much about it, but we are soon going to announce a major change in our in the way we do graphics, and we're working on that at the corporate level that will affect both FieldView and Tecplot 360. Once this new technology is in place, that will allow us to do have new capabilities and faster capabilities for doing feature detections and looking at flow fields in a more dynamic way. So stay tuned.
It could also be that some users aren't familiar with the feature detection type of things that we've done in the past, like the Q criterion and that sort of thing. So
yeah, so it could be that. We also have specific vortex flow features and vortex detection panel where you can compute vortex scores. Encourage the user, if he's not familiar with it, to check our vortex score capability. It's going to connect through lines the core of all the vortices in your dataset. And then it's great for seeding a few streamlines and really highlighting the stronger recirculations in your flow. We can do separation and reattachment lines as well. We can do surface flows. So they all work in conjunction for showing the feeders in your flow. And as you mentioned, Shane, you can also do isosurfaces. We provide native variables for doing Q criterion and lambda 2. So you don't even need to code in the formula. They're predefined, and they work great on isosurfaces for showing your strong vortices as well.
Okay. I think there's another one. Let me look. Yes. Any chance that in the future we'll be able to copy and paste streamlines or be able to assign a name to a streamline? Oh yes, I remember this. The naming of the streamline request.
Okay. Yeah, it's true that we haven't touched that for a while. And yeah, again, something we like to follow up with. I'm not sure if by copy paste the meaning is to copy paste in the same data set, or if that's moving them to another data set. Of course, that's already doable by saving a streamlines restart and applying it to the other data sets if you want to really match streamlines from case to case for comparison. But maybe the request is more for taking a group of streamlines and repositioning them.
Yes.
That's not readily available, but that's a good feature request.
Yeah, it is possible to do something similar with the. There are a few FEX sample examples available through the interface where you can create a disk or a sphere of streamline seeds and move it around. So you could play with that in the meantime. But I think we've logged that feature request. I remember this user asking for this, and I've logged it as a feature request. So thanks for bringing it up again. But that's something we'll take a look at. So another question comes in about, I'm trying to think of the formula. I think it's formula restart. I'm not sure. No, that's not the right one. You tell me. You answer the questions. I'll ask them. All right. The question uh, is it possible to save the environment so that the same environment is loaded every time you load FieldView, i.e. the color of the background, etc.?
Yes, this is called a preference restart in FieldView.
Right.
So that's documented. I know it could be a bit simpler. So what you have to do is you fire up a FieldView session, you adjust things the way you want them, you save these preference restarts. That's going to save a couple of files. And if you put them in your user directory, and we also have other areas that we check that are documented, FieldView will see them at startup and start with those settings. So again, something we can. I know we have a template email from support that we call send to this customer if that helps.
Okay. And that would be like the background color and the view. And
yep, absolutely.
Yeah.
Yep, those kind of things. Yeah.
Perfect. Okay. Well, that was the last question. We're still here, and if you have more questions, feel free to ask them. And again, we will follow up offline with a couple of people that we mentioned already. And I did want to reinforce what Marie was saying earlier, which is that our hope with the client-server configuration is something that a group, a company, maybe your IT group, will do once, and then people can more or less forget about it. But things do change. People will want to take advantage of, for different projects, they may be on different hardware, and the best thing in that case is to get in touch with us and let us help you. Each environment is a little bit different, and we're getting more and more experience as we go on the finer points of these things. And so we're happy to help you, and please do reach out to us. Okay, some more questions coming in. Again, from the person we're going to talk to offline. One is, where is the user directory located?
This is different depending on your environment. So on Windows, it's under local data, Tecplot. If you're on Linux, it's in your home directory. Yeah, if that's regarding the preference restart, it's probably better that we just
send the follow-up.
Yeah, so send a follow-up. That it is a question we answer frequently, so we have a detailed answer for that.
Okay. All right, so we have a couple more minutes. We'll stay on the line and answer any other questions. If you do have questions, go ahead and chat those in. And if there are no other questions, I did want to just say thank you, everyone, for joining us today. We hope you learned things. We hope you'll go and download FieldView version 2023 if you haven't already. And if you're a new person, you're not using FieldView, you could also try it by going to the website and requesting a free trial of FieldView, and you will get the version 2023 to try. So thanks everybody for joining us.